And for the client, it's going to contain the hacker's MAC address, and it's going to associate that with the router's IP address. So what's basically going to happen is it's going to modify the MAC address here, and it's going to change that to the attacker's MAC address instead of the router's real MAC address. So when that happens, then the hacker will be in the middle of the connection, and they'll be able to read, analyze, and modify the packets because they're going to be flowing through the hacker device. So let's run the ARP poisoning, a normal ARP poisoning attack like we always do it. And when I go back here, I'm going to execute the same command. So I'm going to do an ARPA again. And note how the MAC address is going to be different. So the MAC address for the router, it used to be this one. And when we ran the command, then the MAC address changed to this one. And this MAC address right here is the MAC address of the network card that the attacker is using. So if I come here and just do an ifconfig, you'll see that this is the MAC address, the same MAC address that is displayed in here. So this is the easiest and the simplest way to discover ARP poisoning attacks. It's not the handiest way though, because you're going to have to keep doing this command and keep comparing the entries if you really wanted to check if you're being ARP poisoned. So there's a tool called XARP, and it does that automatically for you, and it's available for Linux and Windows. So I already downloaded. You can just Google XARP and you can download it. Very easy to download and install. And I'm just going to run it. I'm actually going to stop the attack first, and then I'm going to run the tool. Now notice when you stop the attack, the IP address is going to go back to what it was. So you can see that the MAC address of the router is back to its default right value of the router. So I'm just going to run XARP now. And you can see that everything is good. And you can see that the entries are very similar to what we did when we did ARPA. So we have the IP addresses and the MAC addresses associated with it. What the tool basically does, it's just going to automatically monitor this. And whenever something changes, it's going to know that something's wrong is happening because each IP address should have a unique MAC address. There should be no duplicates in the network. So I'm going to do another ARP poisoning attack exactly like we did it before. And when we come here, you'll see that XARP is giving us a notification and telling us that something's happening. It's telling us that the MAC address for the router, which is the 10.20.14.1 IP, has changed from this to that. And if we look here, I'm going to click OK. And if we look here, we can see that the affected machines are the router, my own machine right now, and the attacker. Sorry, that's me, and that's the attacker. So basically, we know that the machine at 10.20.14.203 is trying to do an ARP poisoning attack because it's the one that the router's MAC address has changed to. Therefore, we know this is the attacker machine. So this tool is really handy because it does the monitoring automatically for us, and it will tell us whenever someone is trying to ARP poison the network. Okay, so now let's see how we can use Wireshark to discover suspicious activities in our network. And before I do anything, I'm going to go to the preferences. And I'm going to go to protocols, ARP. And I'm going to enable the option to detect ARP request storms. What this will do, it'll actually discover if anybody is trying to discover all the devices on the network, and it's going to give me a notification. So I'm going to click on OK, and I'm going to start my capture. And now I'm going to go to my Kali machine, and I'm going to use NetDiscover. So I'm not going to do ARP poisoning. I'm only going to try to discover all the connected devices to my network. So we're using exactly the same command that we used before, NetDiscover, interface, and the range. I'm going to hit enter. And we can see that NetDiscover finished. It discovered all the devices that we have. So if we come here, even before we look at the output of the notifications, let's just look at the packets that have been generated. You can see that there's a device here. This source is broadcasting, so basically it doesn't have a destination. It's asking all the other devices in the network, and it's inquiring about each possible IP. So it's basically asking who has this IP and tell the 67 IP. And then it's asking who has the 241 IP, tell the 67. Who has the 251, tell the 67. And it's doing this for every possible IP. So it's basically checking if any possible IP in the range exists, and it's asking to return the response to the IP at 10, 20, 14, 67. So from this, we can deduce that someone is trying to discover all the connected devices, and that someone is at 10, 20, 14, 67. Now, if we go on the analyze and expert information, you'll see that we detected an ARP packet storm. So basically it means that there was a single device sending a very large number of ARP packets. So they're probably trying to discover connected devices or trying to discover connected ports. So it's telling us that this person is trying to do something suspicious. Now let's go, and I'm gonna do a ARP poisoning attack, and we'll see if we can get any notifications or warnings in Wireshark. Now I'm gonna go to Analyze and Expert Info again. And if we look, we'll see we have a warning here. And the warning is telling us that there is a duplicate IP address configured. So again, this is telling us that the IP address of the router had two different MAC addresses. What this means, basically, it means that someone was tampering with this and tampering with our ARP table, trying to place themselves in the middle using an ARP poisoning attack. Now, we've seen a number of methods to detect ARP poisoning. Let's discuss how we can prevent it or protect ourselves from it. Now, I'm just going to run an ARPA, and we're going to look at our table. There is switches that will monitor this for you as well, and they'll notify you or even prevent ARP poisoning attacks. Another way to do that is, if you look at here, if you look at your router, you'll see that this entry in the table is dynamic. So the type of this entry is dynamic. What that means, it basically, this can change. It's the system allows this value to be changed. You can see right here, you have static values, which basically means the system will never allow these values to change. So you can use static ARP tables, which basically means that you'll have to configure each IP address. So you have to actually configure your ARP table and map each IP address to the MAC address, to the relevant MAC address. But once you do that, even if someone tries to send a response to your computer trying to change it, the system will refuse to change anything because you configured your ARP table to be static. The only problem with that is every time you connect to a network and every time there is a new device connecting to your network, you'll have to manually configure that device to work with your network. So it's not a very useful solution if you're in a big company or if you're in a big firm, but maybe in a small house or in a small company, then this would be a really good solution to prevent ARP poisoning attacks, because everything is going to be static. You're going to have to set it up manually. But when someone tries to do an ARP poisoning attack, even if their attack is successful and they use the best tools they can, your table is set up in a way that it's fixed. It can't be changed. So the system will always refuse to change the values of the MAC addresses, which will basically mean ARP poisoning attacks will never work against you. Now you have enough information to go ahead and try to gain access to other systems, to computers, servers, web servers, and stuff like that. And in this section, we're going to be talking about gaining access to computer devices. And what I mean by computer devices is anything. And the reason behind this, I want to get this through, I want to get this idea through, is that any electronic device you see is a computer. So a phone, a TV, a laptop, a web server, a website, a network, a router. All of these things are computers. All of them have an operating system, and they have programs installed on these operating systems. And usually, in most cases, these computers are used by a user. So you have an operating system, they have programs installed on that operating system, and they have a user who uses and configures this system. So I'm going to be talking about how you gain access to computers in this example, in actual personal computers. So the name that people call it usually, a computer. So it's going to be, we're going to have a target of a Windows device, and we're going to have a target of a Linux device. But the concept is always the same. Getting access to computer devices is always the same. So you can apply the same concepts if you are targeting a phone, if you are targeting a tablet, if you're targeting a web server. And we will be targeting web servers as well. But I will be talking about it just like a normal computer. This is very important to understand. Every device you see is a computer, and it works just like your personal computer. So I can set up a web server on my computer. I can make it look like a website and act as a website. I can make it act as a TV, and I can make it act as anything I want. And literally TVs and all these things are just simpler computers with less complicated hardware in them. So we're going to be talking about attacking these devices from two main parts, or from two main sides. The first approach that we're going to use is the server side. So in this side, it doesn't require any user interaction. We're going to have a computer, and we're going to see how we can gain access to that computer without the need for the user to do anything, for the user who uses that computer to do anything. This mostly applies to web servers and applications and devices that don't get used much by people. So people basically configure them and then they run automatically. So all we have is going to be an IP address, and we're going to see how we can test the security and gain access to that computer based on that IP. So our main way of getting in is going to be the operating system that target runs and the applications installed on that system. The second approach that we're going to try is the client-side attacks. So this approach will require the client or the person who uses that computer to do something. To do something, that something could be a number of things. It could be installing an update. It could be opening a picture. It could be opening a Trojan. So we're going to learn how to create a Trojan, how to create backdoors, how to use social engineering to make the target person do something. And when they do that action, we will gain access to their computer. Information gathering is going to be crucial in this case because we actually need to know the person that we're targeting. After all of that, I'm going to talk about the post-exploitation. So what you could do after you gain access to this computer, regardless of the method that you gained access to it. So you could have used a server-side exploit, you could have used a client-side exploit, or you could have just got a physical access. The person left their desk and you got in. So we're going to see how what can you do once you have access to your target, how you could further exploit that target and increase your privileges or target other computers in the same place. Now, in the next lectures, we're going to start talking about server-side attacks. I'm going to teach you what a server is, and we're going to talk about that in details. But before we jump into this, we need to have a computer or a machine that acts as a server so that we can try to hack into it. So similar to the way that we had a Windows machine to practice attacks that we can launch against normal users, we need to have another virtual machine that behaves like a server so that we can practice server-side attacks against it and see how we can hack into servers. So the machine that we're going to use is called Metasploitable, and it's a virtual machine that's built on Linux, and it contains a number of services that's typically used by servers. It also contains a number of web applications that act exactly like normal web applications and use the same technologies used by normal servers and normal web applications. So we're going to install this machine, and then in the future, we're going to use it as a target to learn how to hack into servers and how to hack into websites. You can download this from the following link. Now, I've also included this link in the resources of this lecture, which you can access from the top left of each lecture. If you click on this link, you'll get this page, which will allow you to download Metasploitable. Before you can download it, you're gonna have to fill your information in here. So I'm just gonna fill up anything for a company and anything for a phone number. Now, one thing I'd like to note, when it asks you for your email, if you use a normal Gmail account like this one and tries to download, you'll see that it's gonna say this must be a valid company email. So if you do not have a company, you can use a fake email in here. All you have to do is just write a name at any company name you want. So I'm just gonna say zaid@imaginarycompany.com. Now don't use imaginary company as well, because I don't want a lot of people using the same fake email. But the idea is you just want to use a name at some other name.com, and this will allow you to bypass all of this. And once you click on submit, you'll go to the download page, and if we click on download Metasploitable now, it'll download it for me. Now once it's downloaded, you're gonna have a zip file. And I've already downloaded this, so I have the zip file right here. Sorry, not this one, like this one. So once you uncompress it, you'll get this directory. Double click it, and you'll see the following files. So we're gonna create a new machine here, a virtual machine, and I'm gonna call it Metasploitable. And this is going to be a Linux machine. And I'm gonna hit continue. And I'm only gonna give it a gigabyte of RAM, should be enough. And then I'm gonna use, remember with Kali Linux, we created a new virtual hard disk. With this, we're gonna use an existing one. The reason for that is because the image that we have right now is actually, it's designed for VMware Player. So what we're gonna do is we're gonna import the hard disk file or the hard disk image in here, so that we're gonna have a ready installation without having to install it the way we installed Kali Linux. So we're just gonna use an existing virtual hard disk file, and I'm just gonna navigate to select where it is. I'm gonna go into the Metasploitable directory, and I'm gonna select the .vmdk file. So it's this file right here. I'm gonna click on open and create. So we're gonna start this machine right now. Okay, so the machine has run now, it's completely installed. As I said, you don't really need to install anything. We just imported a ready installation, a ready hard disk. So it's asking me for the username, and the username is msfadmin. And the password is the same, so it's msfadmin as well. Now you might notice, once you start typing the password, you'll see nothing displayed on screen. This is a security feature so that the password is not visible to people beside you. So once you get asked for the password, type msfadmin and then hit enter. Now I've actually already typed it, so now when I hit enter, you'll see it's gonna log me in. Now this machine only has a terminal interface, as you can see here, and it's giving you a warning that you should never expose this machine to external internet connection, because it is a vulnerable machine. It is designed to be vulnerable. Now, right now, it's only inside our lab. It's only installed as a virtual machine. So literally nobody outside our lab can access it. So this is a really good way of using it. Now this is it, the machine is installed. As I said, in the future, we're gonna talk about how we're gonna try and hack into this machine. Again, don't be intimidated by the terminal. We're gonna be using it a lot, and we're gonna learn how to use it step by step. So at the moment, we have this installed, and we're gonna move on to the next step, and we will talk about this once we actually need to use it in the future. So if you wanna turn off this machine, all you have to do is just type in power off and hit enter. And it's telling you that you need to be root. So again, I'll talk about this later. For now, sudo power off. So just run the command like this. And it's asking you for the admin password. And that's it, it's going off now. And here we go, the machine is off. Okay, now that we have Vil loaded, you can see it show us the main commands that you can use with Vil. So the first command is you can do exit to exit. You can do info to get information about a specific tool. You can do list to list the available tools. You can do update to update Vil, and this is very, very important because you always want to be up to date when it comes to bypassing antivirus programs. And then you can do use to use a tool. Now, let's start using Vil evasion, and as we do it, it's going to become so easy and you'll be able to understand it more. Now, Vil has two main tools, and if we do a list, you'll be able to see them. So we have the first one, which is the one that we're interested in, which is called evasion, and that's the one that generates undetectable backdoors for us. And then there's the second one, which is called ordnance, and this tool generates the payloads that's used by evasion. So you can look at this as a helper or a secondary tool. Now, what I mean by a payload is the part of the code of the backdoor that does the stuff that we want, that does the evil stuff, if you want to say. So it's the part of the code that gives us a reverse connection. It's the part of the code that download and execute something on the target computer. It's the part of the code that allow us to achieve what we want by executing that file. And this is going to become more clear as we start using Vil. Now, for now, we're interested into using evasion. So we're going to do use 1 because that's the first tool. That's number 1. And as you can see, we have Vil evasion loaded now. And as I said before, this used to be a standalone tool that you just downloaded on its own. But now they have it all combined together. Now, as you can see, the first thing that we get when we load Vil evasion is the commands that you can run on this tool. So the first thing that we want to do is we want to list to see all the available payloads. And as you can see, we have 41 different payloads. And all of these payloads follow a certain naming pattern. And you can see, for example, let's take this example right here because that's the payload that I'm going to be using. You can see the payload is divided into 3 parts. The first part right here refers to the programming language that's the payload is going to be wrapped in. So we have the evil code, and then the evil code is going to be wrapped into a certain programming language that the target computer understands. And right here, you can see that this payload uses Go programming language. We can see this one uses C. We can see these ones use CS. We have Python, we have PowerShell, and we have Ruby if we scroll down. The second part of the payload is really important. This is the type of the payload, the type of the code that's going to be executed on the target computer. In this example, we're using Meterpreter, which is a payload designed by Metasploit. Metasploit is a huge framework for hacking and it allows you to do a lot of things. But in this lecture, we're focusing on creating a payload called Meterpreter. And what's really cool about Meterpreter is it runs in the memory and it allows us to migrate between system processes. So we can have the payload or the backdoor running from a normal process like Explorer, for example, and this payload will allow us to gain full control over the target computer. So we'll be able to navigate through the file system, download, upload files, turn on the mic, turn on the webcam, even use that computer to hack other computers, install a keylogger. You can literally do anything you can think of. And all of this will be running from the memory from a normal process on the system. So it's very hard to detect and it doesn't leave a lot of footprints. That's why it's a really, really cool payload and we'll be using it a lot. The third part of the name is the method that's going to be used to establish the connection. So in here you can see that this is called rev HTTPS. So rev stands for reverse and HTTPS is the protocol that's going to be used to establish the connection. So we can see that this payload will create a reverse HTTPS connection. You can see this one right here, for example, it creates a reverse HTTP connection. And we have this one in here that creates a reverse TCP connection. Now, what I mean by reverse is the connection is going to come from the target computer to my own computer. So I won't be connecting to the computer that I want to hack. What's going to happen is once the person double clicks the backdoor will connect back to me from the target computer. What's cool about this is I'll be able to bypass antivirus programs because the connection is not going to the target computer, it's coming back to my computer. So it's literally as if the target person is just connecting to a normal website. I'm going to use a port that websites use, which is 80 or 8080. So again, if the person analyzes the connection, it'll look as if they're literally just connecting to a normal website. Also, if the target computer is hidden behind a router or behind a network, again, this is going to work because the connection is coming from the target computer to me instead of me connecting to the target computer. So using a reverse connection is really, really handy. And I think this is really the only practical way of gaining access to a computer because there is a lot of things that can stop you from connecting to a certain computer. Now, this is the general naming pattern. You'll see some payloads like this one right here, which doesn't follow that general naming pattern. And basically what these payloads do, for example, you can see this one is called shellcode inject. So what it's going to do is it's going to create a payload that injects your other payload. So it's going to create a normal payload, and that normal payload injects a Meterpreter payload, for example. Now it does this to try to bypass more security, but usually they won't bypass more things than the normal payloads would bypass. So that's why I usually just use one of the normal payloads in here. So this is it. This is all about the payloads. Sorry I took a bit of time, but I wanted to make sure that you guys understand the naming pattern. I wanted you to understand what a payload is and the difference between a reverse and a bind and a TCP payload. This way, the rest of the course will become more clear to you, and I can just use the payload that I want without explaining what it is. Now, in the next lecture, we're going to be generating a payload, and we'll be testing it against antivirus programs. So, the first thing we're going to look at is the server-side attacks. And again, these are the attacks that don't require user interaction. You can use these attacks with servers, so web servers and stuff like that, and you can also use it against normal computers that people use every day. The reason why I'm going to be using it against an application, against my Metasploitable, which runs Unix and which is more of a server than a normal personal computer, is because if your target uses a personal computer and if they're not on the same network as you, then even if you get their IP address is going to be behind the router, so they'll probably be connecting through a router. And therefore, if you use the IP to try and determine what operating systems run on it and what applications are installed, you will not get much useful information because you're only going to be getting information about the router and not about the person, because the person is hiding behind the router. Whereas when you're targeting a web server or a server in general, then the server will have an IP address, and that IP address, you can access it directly on the internet. So this attack, or these ways of gathering information that we're going to look at now, will work if the person is on the same network and if the person has a real IP. So if you can ping the person, even if it's a personal computer, if you can ping it, then you can run all of the attacks and all of the information gathering methods that we're going to explain now. So in my example, I'm going to be targeting my Metasploitable machine here. And before I show you anything, first of all, I want to show you the network settings. So it's set to NAT and it's on the same network as my Kali machine. So the Kali machine is going to be my attacking machine. And again, on the network, it's set to NAT network and it's on the same subnet. Now, this is very important. So in here, if I do ipconfig, or if I do ifconfig, sorry, you'll see that my IP is 10.20.14.204. And if I go to my Kali machine, I should be able to ping it. Now, if I can't ping it, then we won't be able to do anything. And as you can see, we're getting responses back from the machine. So we are connected to that machine and we can get responses from it. Therefore, we can try and test its security. So again, you can use these attacks and you can use these approaches against any computer that you can ping. So if it's a personal computer or if it's a server of any kind, as long as you can ping that direction or you can ping that person, then you can use these attacks and these methods that we're going to talk about in the server-side attacks. So it's going to work against websites, web servers, people, normal computers, as long as you can ping them. And just to convey this idea, now we see the Metasploitable machine right there. So it's just a normal machine. It's a normal virtual machine that I can use right here to do anything I want. I can list, I can even install a graphical interface, and then I'll be able to do, just use it just the way I use my Kali machine. But at the same time, it has a web server. So if I try to navigate to it from here, you'll see that I actually have a web server here, and it has websites that I can actually read and browse. And we're actually going to have a look on these websites and see how we can pen test them in the future. So everything is a computer. If you can ping that IP, you can use the server-side attacks. It mostly works against servers because servers always have real IPs. And also, if the person is in the same network as you, then you can ping them and you can do all of these attacks as well. Right, so the first step into the server-side attacks is information gathering. Information gathering is very important because it will show us the operating system of the target, the installed programs or the running services on the target, the ports associated with these services. Now, from these installed services, we can try and get into the system. We can do this by trying the default passwords, and we've seen this before in the network penetration testing part, where the iPad had a SSH service installed, which basically give you full access to the computer if the person still uses the default password, which was Alpine. So we can do this with any other service, and we'll see another example here today. Another thing that we can do is there's a lot of people install services and misconfigure them. So we'll have another example of this. So sometimes a lot of these services are designed to give some remote person some access to that computer, but they obviously need to have some security implementations. People often misconfigure these services, so we can take advantage of these misconfigurations and gain access to these computers. Another problem with these services, some of them might even have backdoors, and we'll see an example of that. And a lot of them would have vulnerabilities such as remote buffer overflows or code execution vulnerabilities that allow us to again gain full access to that computer. Now, the simplest way on doing this is something that we've seen before, which is using ZenMap. So we use ZenMap using the IP. We get a list of all of these services and then Google maybe each one of them and see if they contain any vulnerabilities. Now, we've seen how we use ZenMap before, but I just want to convey the idea of anything is a computer, and we've seen before how the Metasploitable device, this device is actually a website. It has a web server running, so websites are nothing different than this. If you want to get an IP of a website, all you have to do is just do a ping. So for example, if we're targeting Facebook, so all we have to do is do ping facebook.com. And we'll get their IP right here. So we have Facebook's IP, and we'll be able to run ZenMap against it and get a list of all the running services on Facebook. Now, obviously, I'm not going to do that because I'm not allowed to do that. What I'm going to do is I'm going to run ZenMap against this Metasploitable device, which basically is a computer device, and that's what we're interested into testing. So again, I can't really stress this anymore. Anything is a computer, whether it's a website, a server, any online service, a phone, anything is a computer. So you can go about penetration, anything the same way. So I'm going to run ZenMap, just the same way that we did before. So I'm going to go on my activities. I'm just going to look for ZenMap. And here's ZenMap. And I'm going to put the IP of my target of the Metasploitable device, which was 10.14.04. So remember, in the network penetration testing part, we used to put the base IP and put it over 24 to cover all the IPs around us in the network. In this case, you might be testing a remote IP. So for example, in the Facebook case, all you have to do is just put the Facebook target IP in there and test it. Now that's granted that you have permission to do that. Now I don't have permission, so I'm not going to do that. What I have permission to do is test my own device, which is installed on the same network as me. So that's why I'm putting that IP. But you can literally put any IP you want in there and test it. So I'm going to hit on scan. And this will give me a list of all the installed applications. Okay, so the scan is finished now. And we have a lot of open ports, a lot of services. What I advise you to do in this case now, if you want to do a simple test, is you literally go on ports, port by port, read what it is, and Google the name of the program. So for example, we have port 21 here. That's an FTP port. FTP is a service that it's installed to allow people to upload or download files from the remote server. So we can see usually FTP services use a username and a password, but you can see that this service has been misconfigured and it allows anonymous FTP login. So unlike the SSH that we used before in the network penetration testing, we used the default password. With this, you'll be able to log in without a password. So all you have to do is download an FTP client such as FileZilla, and you'll be able to connect using this IP address on port 21. Now I'm not going to explain this because it's very simple. You literally download the application and connect to it. What else you can do is you can Google this. This is an FTP server. You can literally Google this and see if it has any issues, if it has any misconfigurations, if it has any known code execution exploits. So I know if you Google this now, this particular application has a backdoor installed with it. So it literally came with a backdoor when it was released. For now, I'd like to show you something simpler, just so that we make this shorter. So, as I said, you need to go in one by one, Googling the services, and checking if they have any misconfigurations or any exploits installed, or if any known exploits. So what I'm going to do now is I'm going to have a look on the 512. So let's assume we went on them one by one, we couldn't find anything, and we reached the 512 TCP port. So I'm going to copy this. This is the service that's running on this port. So literally, I don't know what's this. So I'm going to copy it, go on Google and Google it. Okay, so we're going to have a look on the first result that we got here. And we can see that this is a remote execution program. So that's very nice. That's very cool. So if we manage to log in with this, we'll be able to execute commands on the target computer. And it uses the RSH rlogin. That's a program that ships with Linux that allows you, similar to SSH in a way, that lets you execute remote commands on the target computer. So let's go back and see how we can connect to this. So this is all cool. So let's see the package, what comes in with this package. So, and you can see this is Ubuntu. So the target computer system was running on Ubuntu. If we go back. So it's running on Ubuntu here. And you can see that in here, it uses the RSH client service to connect. So this is the package that you need to install to connect to the service. So, and as you can see, it says client program for remote shell connection. So go back and let's install RSH client. So we usually, as we did before, when we need to install something, we do apt-get and we do install, and we'll write the name of the program that we want to install. So it's RSH. Now apt-get is going to install it for me and configure it. And once it's installed, we're going to use rlogin to log in, because remember the first page told us that it uses the rlogin program to facilitate login process. So I'm going to do rlogin. And again, I don't know how to use this app, so I'm going to do the help to see how to use it. And we can see that the format is rlogin. You put the options that you want. So what's important here is the username and the host, which is the target IP. So this is what we're going to do. We're going to do rlogin. We're going to put the username as root. Again, we said root is the user with the most privileges on the system. And we'll put the target IP, which is 10.20. Now, as you can see, now we are logged into the Metasploitable machine here. And if I do ID to get my ID, you can see that I am root. If I get where I am, pwd, I'm in the root directory, I can list stuff. If I do a uname a, that'll list the host name and the kernel that's running on the machine. And as you can see that I am in the Metasploitable machine with the root access. So this was a manual way, a basic way of gaining access to the target computer only by a misconfiguration of an installed service. So the rlogin service was not configured properly. All we had to do is just Google what came with that port, and we managed to find, or we managed to log in and gain full access to the target computer. Now again, the key point here is you do a Zenmap scan, and then you go on each port that you find, you Google that port, and you'd be looking for misconfigurations, default passwords, if this target service came in with a backdoor, or code execution. Maybe it just wasn't programmed properly, or it had a flaw that can be used to gain access to that computer. Now we'll have examples of these things in future videos as well. Now, the backdoor that we created uses a reverse payload. So, like I said before, it does not open a port in the target computer. It actually connects from the target computer to our computer. And by doing that, it'll bypass firewalls and it'll look less suspicious. So for this to work, we need to open a port in our computer so that the backdoor can connect from the target computer to us on that port. So if you remember, when I created the backdoor, I set the port to 8080. So I need to open that port in my Kali machine so that when the target person executes the backdoor can connect back to me on port 8080. So I'm just going to write the name of the payload that we used, because that's very important when you're listening for incoming connections. So we used a payload that's written in Go, and that was a Meterpreter Rev HTTPS, which is a reverse HTTPS payload. Now this is not a command, I'm just going to write it in here, so just that you keep this in mind. And we used port 8080 for the reverse connection. So these are the most important things to keep in mind when listening for incoming connections. So I'm going to split the screen, and I'm going to listen for incoming connections in here. And to do that, I'm going to use the Metasploit framework. Now to run Metasploit, all you have to do is just run MSF console. Now Metasploit framework is a huge framework for penetration testing. So the Meterpreter backdoor, or the Meterpreter payload that Vil created for us, is actually programmed by the people who made Metasploit. That's why we're using Metasploit to listen for incoming connections. So Vil Evasion actually uses Metasploit to generate the backdoor that we chose in the previous video. So to listen for incoming connections, we're going to use a module in Metasploit. Now Metasploit, as I said, is a huge framework, and it has a lot of modules. So the module that we're interested in is a module that allows us to listen for incoming connections from a Meterpreter payload. To use that module, we're going to do use to use a module, and then we're going to specify the module name. And the module name is exploit multi-handler. Okay, so the command we're using is use to specify the module that we want to use, and we're using a module called exploit multi-handler that allows us to listen for incoming connections. I'm going to hit enter. And I was already in that module, so you can see that nothing changed for me, but for you, you should navigate to that module. And I'm going to do show options to see the options that I can set for this module. And you can see that you can specify different options for it. the most important thing that you want to specify is the payload. So you can see in here, for me, it's set to Windows Meterpreter Reverse TCP. And if you remember what we used a Meterpreter Reverse HTTPS, not TCP. So you want to change this. The first part is fine because our target is going to be Windows, but you want to change the reverse TCP to reverse HTTPS. And you can change that exactly the same way that we did with VIL evasion. So you type in set, you put the option name that you want to change, and we want to change the option for the payload. So we're going to say payload. And we're going to set that to Windows Meterpreter Reverse HTTPS this time. Okay, so we're doing set to set an option. We're setting the payload to Windows Meterpreter Reverse HTTPS. Now this payload should correspond to the payload that you chose in the backdoor. So in the backdoor we used Meterpreter Reverse HTTPS. That's why in here we're using Reverse HTTPS as well. If you chose Reverse HTTP, then set this to Reverse HTTP. If you use Reverse TCP, then set this to Reverse TCP, and so on. So I'm gonna hit enter for this, and that's gonna do it for me. And if I do show options now, you'll see the payload changed to Windows Meterpreter Reverse HTTPS. Now the same concept applies for all the other options. So you want to set the lhost to our IP address, and you can see that this is already set to the right one. So if it was wrong for you, all you have to do is just do set lhost and put your IP address. So you can get the IP address using ifconfig like I showed you in the previous lecture. So for me it's 10.20.14.213, and again this is the same IP that I used when I created my backdoor. And same goes for the port. You want to set the same port. So we're going to do set lport to 8080. Because that's the port that we used when we generated the backdoor. So again, the main idea with this is you want to set the payload, the lhost, and the port to exactly the same options that you chose when you created the backdoor. Once done with that, we're going to do show options one more time. And you'll see that I have my payload set properly, Windows Meterpreter Reverse HTTPS. I have my lhost, and I have my lport. And all of that is done properly. So all we have to do now is just do exploit. And now Metasploit is waiting for connections, as you can see, on port 8080 and on my IP address, which is 10.20.14.213. So now if anybody opens the backdoor that we created in the previous lecture, because it's a reverse backdoor, the backdoor will try to connect to the IP that we set when we created the backdoor, which was 10.20.14.213, and it'll try to connect on port 8080. It's gonna come to this computer, and this computer is already waiting for that connection from this multi-handler module. So the connection will be established, and then I'll be able to control the target computer, and I'll basically hack it and have full control over it. Now in the next lecture, I'll show you a very basic way to deliver the backdoor to the target computer and how to test the backdoor and make sure that it works properly. Okay, so in this video, we're going to be using VIL to create a backdoor. So the first thing I'm going to do is I'm going to do list to list the available tools, and I'm going to use number 1 because we want to use evasion. And then I'm going to list my payloads. And like I said in the previous lecture, I want to use Go Meterpreter Reverse HTTPS. So that's number 15. So I'm going to do use 15. And that's going to list first of all, it's going to show me information about this particular payload. And then it'll show me the options that I can set for this payload. So the main option that you want to set, and the most important one, is the IP address. So this is the IP address which you're going to be receiving the connections on. As we said, we're going to have a reverse connection, and we need to set the IP address which the payload or the backdoor will try to connect back to. And in our case, we want to receive the connection back to this Kali machine. So we're going to set the IP lhost to the IP address of the current Kali machine. Now to get the IP of my Kali machine, I have to run ifconfig. So I'm going to split the screen by doing right click and click on split horizontally. And I'm just going to bring this down a bit. And we're going to run ifconfig. Now you can see the IP address in here is 10.20.14.213. This is the IP of my Kali machine. This is the IP of the machine that I'm using as the attacking machine. So this is where I want the connection to come back to, so I can hack the target computer once the backdoor is executed. So I'm going to set lhost to 10.20.14.213. So you can set any of these options using the set command. So all you have to do is write set followed by the option that you want to change. So in this case, we want to change the lhost, and we want to change that to 10.20.14.213. Now, the L port is set to 80, which is really good because that's the port that's used by web servers. So as I said, the connection will look as if the target person is connecting to a website, and it's not going to be suspicious. But I don't want to use that port because I'll have a web server running on this, and we'll talk about that later. So I'm going to change that to 8080. 8080 is another port that's used by web servers, so it's still not suspicious, and it should still bypass firewalls. So I'm just going to do set. Same way that we did it before with the lhost, we're going to do lport to the value that we want to set this option to, and we're going to set it to 8080. Now, if I do options again to list all the options, you'll see that the lhost changed to 10.20.14.213 and the lport changed to 8080. Now, if you generate the backdoor like this, you will bypass all antivirus programs except AVG. I've already tried this, that's how I know this, and that's not good enough because we want to bypass everything. Now, the way antivirus programs work is they have a very large database of signatures. These signatures correspond to files that contain harmful code. So what they do is they compare the signature of your file, of your backdoor, to all the files in this huge database. If your file matches any of these files, then they'll flag it as a virus or as malware. If it doesn't, then they'll think that it's a normal file and it's not malware. So the main point in here is we're going to try to modify the file, our backdoor, as much as possible to make it more unique so that it bypasses the signature database and will be able to bypass antivirus programs. Now, as I said, Vil is already doing that for us. It's encrypting the backdoor, it's obfuscating it, it's injecting it in the memory so that it doesn't get detected, and it's doing a good job at it. It's bypassing pretty much everything except for only one antivirus program. So just to bypass this last antivirus program, I'm gonna set some optional options that really won't do much of a difference. They'll just make the backdoor look a bit different. So the first thing that I'm gonna modify is processors. And that's the minimum number of processors to be used by the backdoor. I'm not going to set a huge number because that will just make my backdoor not work. I'm just going to set it to 1, which is pretty much nothing really, but I'm just going to set this option to make the code look a bit different. So I'm going to do set. Again, the same way that we are setting the lport and the lhost, we're just going to put the option name, which is processors. And we're going to set that to number 1. And I'm also going to set another option, which is the sleep option. And that basically lets the backdoor sleep for a number of seconds that you set before it executes the evil code that you have in there, before it executes the payload. So I'm going to set this to 6. Again, no real reason for this. I'm only doing this to make the backdoor look a bit different. So I'm going to do set sleep to 6. So I'm going to hit enter. And I'm going to do options again to make sure that all the options are set the way I want them to be. So I have my IP address set properly. I have my L port. I have my processors, and I have my sleep. So I'm going to generate the backdoor. And now it's asking me to name this backdoor something. So I'm going to name this backdoor rev HTTPS 8080, just so that we can remember which payload and which port to use for this backdoor in the future. Now the backdoor is generated, and you can see it's telling us the module that's used, and it's telling us where the backdoor is stored. So the backdoor is stored in this path right here. So I'm going to copy that. Let's go ahead and check to see if the backdoor is detected by any antivirus programs. Now you can use the built-in feature by VIL using the check VT command, but this feature only uses the signature of the file, and it's not 100% accurate. Sometimes it tells you that the file will bypass all antiviruses, but it'll actually be detected. You can also use VirusTotal, but I don't recommend that, and please don't do that, because if you do that, your backdoor will become less effective, because VirusTotal share the results of their scans with antivirus programs. What we're going to do is we're going to use a website called NoDistribute. So we're going to go to it now. So I'm just going to Google for NoDistribute. And what this is going to do, it's similar to VirusTotal. The only difference is it's not going to share the scan results with antivirus programs, so it won't affect your backdoor. So I'm going to click on Browse to navigate to my file. And I'm just going to copy where the file is stored. So VIL is telling me now it's stored in this location in user share VIL output compiled. So I'm going to copy this. And I'm going to come here. I'm going to click on the pen. And I'm going to paste the location. I'm going to click on Open and scan the file. Now, as you can see, I've already scanned this file, and it's telling me that this file has been scanned before. So I'm just going to click on View Previous Results. And as you can see, the file is actually scanned on the same day as today, which is the 29th of March, 2017. And as you can see, the file is bypassing all antivirus programs. So we can use this backdoor against any device, and we'll be sure that the device or the computer will not be able to detect this file as a virus. Now there's a few things to keep in mind. Antivirus programs always update their database, and VIL always update their code as well. So you want to always make VIL up to date. Also, sometimes with the same exact backdoor, it might get detected and it might not get detected, because depending on the way the backdoor is getting encrypted and it's getting generated. I've actually generated this backdoor before with no sleep, and as I said, it got detected by one antivirus program. I generated with 10 seconds and it still got detected, and then with 6 it was able to bypass it. So you want to keep playing around with the options, you want to keep playing around with the payloads until you manage to achieve the best results so that you can bypass as much antivirus programs as possible. So far we've seen how we can use a service with a default password, or a service that has not been configured correctly, or a service that came with a backdoor to gain full access to the target computer. We also seen how the basic use of Metasploit using to connect to a backdoor that was installed on the FTP service. Today we're going to have a more advanced look on Metasploit, and we'll see how we use it to run a vulnerability that exists in a certain service. It's a code execution vulnerability, which will give us full access to the target computer as well. So back to our results here with Nmap, and we're going to do the same thing that we've been doing for a while. We copy the service name and see if it has any vulnerabilities. So for today, we're having a look on this particular port 139, which has a Samba server version 3.x. So 3 point anything really. So we're going to go to Google, just like we did in the previous videos, and we're going to look for Samba 3x exploit. Now, as you can see, there's a number of results. The one that we're interested in, the ones that come in from Rapid7, because as I said, these are the people that make Metasploit. So the exploits that you see there can be used through Metasploit. So we have two examples here. Now I've actually tried both. The first one doesn't work, so there is a bit of trial and error in this. And the second one is the user map script. It's a command execution vulnerability, as you can see here. So the name of the vulnerability is this. So it's the same thing that we used before with the evil backdoor in the FTP service. This is just a different name that we're going to use. So I'm going to go to Metasploit, and I've already run MSF console. So you can see that the console is running here for me. So I'm going to do a use like we did before yesterday. And then I'm going to put the name of the exploit that I want to use. Then the next thing that we usually do is show options like we did yesterday. So I'm going to do show options. So using these exploits is always pretty much the same. The only difference is the options that you can set for each exploit. So you always do use and then you put the exploit name, and then you do a show options to see what you can change to work with this exploit. So in the future, you probably will get different exploits than what I have. So every time you want to run an exploit, you do a use exploit name, and then you do show options to see the options that you want to configure. But using the exploits and setting the options and running them is always the same. So I'm showing you a few examples that should cover pretty much everything that you want to do in the future. So again, we need to set up the rhost, which is the IP of the target computer. And we're going to do it the same way that we did before. As I said, it's setting the options is always the same. So we're going to do set rhost, and then we're going to put the IP of the target computer, which is 10.20.14.204. So exactly like we did before, we're using the set to set an option, which is the rhost. So we're going to do a show options. And as you can see now, the rhost has been set correctly. What we need to do now is, here is where things differ from the previous lecture. In the previous lecture, we used a backdoor that was already installed on the target computer. So all we had to do is connect to the backdoor, and then we could run any commands, any Linux commands on the target computer. In today's video, the target computer does not have a backdoor. It has a normal program that has a buffer overflow or a code execution vulnerability. So the program doesn't have any code that allow us to run Linux commands. It has a certain flaw that will let us run a small piece of code. These small pieces of code are called payloads. So what we need to do, we need to create a payload and then run it on the target computer using the vulnerability that we found. That piece of code will allow us to do different things. So the payload is what allows us to do things that are useful to us. Now the payload might let us do Linux commands, and there is other type of payloads we'll look at in the future. So to see the payloads that you can use with this particular exploit, all you have to do is run show payloads. And these are the different type of payloads that you can use. Now I'm going to talk about this again. So payloads are small pieces of code that will be executed on the target computer once the vulnerability has been exploited. So when we exploit the vulnerability, the code that we're going to pick here will be executed. And depending on the type of payload we choose, that payload will do something that is useful to us. So right now you can see that all the payloads are CMD. So that's short for command. So they let you run commands on the target computer, just like Linux commands. And all of them only run on Unix, and that's okay because our target is Linux. And there is two main types. There is bind payloads and there is reverse payloads. The bind payloads, all they do is they open a port on the target computer, and then we connect to that port. The reverse, they do the opposite. So they open a port in my machine, and then they connect from the target computer to my machine. This is useful because the reverse allows us to bypass firewalls. So the firewall will filter any connections going to the target machine. But if the target machine connects to me and I don't have a firewall, then I'll be able to bypass the firewall. So I'm going to use the CMD Unix reverse, or actually I'll use the CMD Unix reverse netcat. The last parts of these payloads are the programming language or the tool that's going to be used to facilitate the connection. So for example, you can see there's payloads written in Perl, in Ruby, or in Python, PHP, or using Netcat, which is a tool that allows connections between computers. So this is the one that I'm going to use. And I'm going to use it the same way you use an exploit. So I'm just going to say, I'm going to use it using the set command. So the same way you set an option, we're going to set payload, so just like an option, to the payload name that we just picked. Now I'm going to do a show options to see if there is any other options that I need to set. And yes, because we picked a payload now, there is more options. So there is an option called lhost, and it's the listening address, which is my own address. So I'm going to get my own IP address using ifconfig. And my own address is 10.20.14.203. So I'm going to close this. And I'm going to set the lhost. So it's like the same way that we set the rhost before. We set the lhost to 10.20. So before we used to do set rhost to set this option. Now we're setting the lhost to set this particular option. So set is really simple. Set, you put the option name and then the value that you want to set it to. Then I'm going to do show options. And now everything seems fine. So we're using this exploit. The rhost is set to this, which is okay. And then the lhost is set to this, which is perfect. And then you can also set the port that you're going to be listening on your current computer. You can actually set it to 80 if you wanted to. That's the port that is used by web browsers. So if you set the L port to 80, the target computer will try to connect to you using port 80, which is never filtered on firewalls because that's the port that web browsers or web servers use. So whenever you access a website, you actually access port 80 on that website. So if you open port 80 on your machine and the target connects to you on 80, then the firewall will think that the target is only browsing the internet. I'm not going to do that now because I have a web server running on port 80 and that will conflict. So I'm just going to set the L port to 555, just for example for you, just to see that you can change any option using the same way, which is set, the option name, and then the value. So I'm going to do show options again. And as you can see, this has been changed to 5555. And I'm going to do exploit to run the exploit. Now, as you can see, it's telling me that session 1 has been opened and the connection is between this device and this device, which is the target and my device. So I'm going to do a PWD or I do an ID. You'll see that I'm root. If I do a uname A, you'll see I'm in the Metasploitable machine. And if I do an ls, I'll be able to list the files and so on. I can use any Linux command just like we did before in the other videos. Now we're ready to receive connections from our backdoor. So we created the backdoor, we set a payload, and we're listening for incoming connections here from any connection that comes in from the same backdoor on the same port on the same IP. So now if a person runs that backdoor, we'll receive the connection back in here on this computer. What we're gonna do now is we're gonna test the backdoor to make sure that it works. And to do that, we're gonna use a very basic delivery method. Later on in the course, we're gonna talk about smart delivery methods that will trick the person into opening the file that we're sending to them. For now, we're just doing a very basic example just to test our very basic backdoor. So to do that, we're just gonna put the backdoor on our web server and then download it from the target computer. So there's nothing smart about this, and you probably can't use this way to deliver the backdoor to a real person. So we're only doing this for testing to make sure our backdoor works. So Kali comes in with a web server, and what that means basically you can use Kali as a website. So what we're gonna do is we're gonna put that backdoor in that website and then just download it from the target Windows machine. Now the website directory where you should store the website files is var www.html. So I'll show you where it is now. If you just click in here on the path and then put a /, it will allow you to manually type the path that you want to go to. So we want to go to var www.html. And this is the location where the website files are stored. Now for you, you'll probably only have index.html, you won't have all of that stuff, but that's just stuff that I created while I was testing a few things. So the index is the main page that people usually see when they browse to this website. So what I'm gonna do here is I'm gonna first of all create a directory and I'm gonna call it evil files. So every time we create a backdoor or a keylogger, we're gonna put it in here and then download it in the Windows machine to test it. And again, later on in the delivery methods section, we're gonna talk about smart delivery methods. For now, we're only gonna be creating the evil files and test them to make sure that they work as expected. So I'm gonna call this directory evil files. And inside it, I'm gonna put the backdoor that we created before. So the backdoor that we created was made using Villavision, and Villavision actually gave us the full path of it when we created it, if you remember, or you can go back now to the lecture and have a look on it. So I'm just gonna press Ctrl-T to open a new tab, and then again I'm gonna click on the path in here, and I'm gonna put / to manually enter the path, and then we're gonna go to var lib Villavision output compiled, hit enter, and you'll see the backdoor that I created right here, and we named it rev https 8080. So I'm gonna copy this and paste it in here. And that's it. Now we can download this file from the website that Kali uses, that Kali has. Now to start the web server, to start the website, we have to start its service from the command prompt. And to do that, we're going to do service Apache2 start. So the command is service to start the service. Apache2 is the name of the web server. And then we want to start this web server. I'm gonna hit enter, and because we didn't get any errors, that means the command got executed properly. Now everything is done. So the IP of the Kali machine was 10.20.14.2.13. It's the same IP that we're listening here, and it's the same IP that you'd get if you run ifconfig. So I'm gonna go to my Windows machine, and I'm gonna navigate to my IP address of the Kali machine, which is 10.20.14.2.13. And this will open the basic index.html that I showed you. And it basically just says it works, telling us that the web server is working and the website is working. This is all inside var www.html. So if I wanted to go to the directory where we put the backdoor, then we're just gonna go to evil files because we called it evil files. I'm gonna hit enter, and you can see the backdoor that we created in the previous lecture, and we called it rev https 8080. So if I click on that, it's gonna download it for me. And like I said before, this is not the smartest way to deliver the backdoor, but right now all we want to do is just to test the backdoor and make sure that it works. So if I click on the downloads and run the backdoor, it's going to tell me that this is an executable, so be careful when you run it, but this is not detecting a virus. It's literally just saying be careful when you run exes. I'm going to run it anyway, and once we come back here, you'll see that we received a connection from the target machine. So we didn't connect to the target computer. The target computer connected back to us. So you can see the IP of the target computer, which is 10.20.14.206, and that IP connected back to us on port 8080 right here. So basically now we have full control over that computer. Right here you can see that we have a Meterpreter session, and what Meterpreter allows us to do is literally do anything that the user can do on their computer. So we'll see how we can use the Meterpreter later on in the post-connection attacks. For now, we can see that the backdoor is working, and if we do sysinfo, you can see that we are inside the MS Edge Windows 10 machine. It's Windows 10 right here. It's x64. It uses English US, and it uses a Meterpreter x86 for Windows. So as I said, now we can do anything we want on the target machine, and we'll talk about how to use the Meterpreter later on in the post-connection section. But again, basically right now we hacked the target computer and we have full control over it. So far in the server-side attacks, we've seen how we can use a default password or use a misconfigured service to gain access to the target computer. Today we're going to have an example on a very simple thing, which is a backdoor. So some programs or services were shipped or come in with backdoors embedded in them. So we're going to exploit that today. And I chose this very simple exploit because I want to introduce you to a framework called Metasploit. We're going to be using that framework a lot, so I wanted something simple to start with, and then we're going to go deeper into that framework. Now first, let me show you how we find that exploit. So again, using the same method that we've always been using, I have my Nmap scan, and as I said, we're going to go on each port and Google them looking for exploits. So I'm going to Google the service name here, and I'm going to go to my browser, go to Google, and I'm going to type in exploit. So the service name and followed by exploit. And as you can see, the first result comes in from a website called Rapid7. Now, Rapid7 is a company that makes Metasploit framework. So that's why I chose this particular exploit to show you today. So let me go back and let's talk about Metasploit for a second. So we're going to exploit this service or this problem using Metasploit. And as you can see here, Rapid7 is telling us that this version of FTP has a backdoor command execution. So it allows us, we can basically execute commands on the target computer if it has this program installed. And from Nmap, we know that this program is installed, which means that we can execute commands on the target machine. So I'm coming back here and I'm going to go to the next slide, which talks about Metasploit. Now, Metasploit, as I said, is made by Rapid7. It is a huge framework that contains a large number of exploits. So it allows you to exploit vulnerabilities or create your own exploits. If you are an expert and you know how to discover and make exploits, then Metasploit will help you do that. Now, for today, we're doing a very simple use of an existing vulnerability. So the commands on Metasploit are very easy. They might seem a bit complicated now, but once you get used to it, it is very easy to use. And a lot of them are generic commands. So here I'm showing you the basic generic commands, and then there are other commands that you get used to them in time. So the first command is MSF console, and this basically just launches Metasploit program. You can always type in help at any stage and you'll get help of the commands and their description on how you can use them. You can use the show command to show something. So you can show the available exploits, you can show the available auxiliaries, the available payloads, and we'll talk about what each of these mean in the future. You can use the use command to use something that you've shown. So for example, you showed exploits and you picked a certain exploit that you want to use. Then you use the use command and then you type in the exploit name to run it. Then you can use the set option or the set command to set specific options for the exploit. For example, if you wanted to set the IP address of your target, so you set the IP and then you put the value of the IP that you want to set it to. And then at the end, once you finish configuring your exploit, you can type in exploit to execute that exploit. Now, I know this might look a bit vague, but once I use it, it's going to become very clear to you. And we're going to be using these programs a lot, these commands a lot, so they're going to become very easy and simple to use. So we're coming back here. So we went on Nmap, we Googled the name of the service, and the first thing that came up is that this service has a backdoor command execution. Because this is on Rapid7, the vulnerability is exploitable using Metasploit. And the module name that we're going to be using is this. So it made our life much easier with this. So I'm going to copy the name. This is the name that I want to use to exploit this vulnerability. So I'm going to go to my console and I'm going to launch Metasploit using the command msf console. And we're going to do a use and then put the name of the exploit that we just copied from Google or from Rapid7. So we're going to use that certain exploit. And as you can see now, the name here changed to exploit and then the name of exploit that we're using. Then we're going to use the show command to show the options that we need to set. So as I said, show is a generic command that you can use it in a number of cases. So in this case, we're doing a show options to see all the options that we can change for this particular exploit. And as you can see now, the second option is the port that the service is running on, and it's already set to port 21. And this is correct. If we go back to Nmap, you'll see that our target FTP client or server is running on port 21. So this is good. We don't need to change any of that. What we need to change is the rhost. So the rhost is the target IP address, as you can see here. And to change the value of this, as I explained before, we're going to use the set option or the set command. So our command is going to be set, and we're going to set the rhost, and that's the IP address of my target Metasploitable machine. So we use set, and after set, you put the option name. So for example, if you wanted to change the port, you set rport. We are changing the host, so we set rhost to 10.20.14.204, and I'm going to hit enter. And as you can see now, this is the rhost is set to this. Now what I want to do is show the options again, just to make sure that everything is configured correctly. And as you can see now, the rhost has been changed to 10.20.14.204. So everything is ready now, and to execute the exploit, we just type in exploit. So it seems like the exploit ran, but nothing has happened. We didn't gain anything. So what I'm going to do is just run it again, and this happens sometimes. And as you can see now, the exploit was run successfully. And now I have access to the target computer. If I do an ID, you'll see that my ID is root. Now basically I'm running Linux commands here. So if you do a uname a, you'll see that this is my Metasploitable machine. And if I do ls, then it'll list the files for me. If I do pwd, it'll show me where I am. And I can use Linux commands to do anything I want on the target machine. Now this was a very simple use of Metasploit. In the future, we're going to be using it for more advanced stuff. In this section, we're going to start talking about client-side attacks. So most of the time, it's better to try to gain access to your target using the server-side attacks. So try to find exploits in the operating system and in the applications installed. If you tried that and it didn't work, or if your target is hidden behind an IP, so if the target person is not in the same server as us, on the same network as us, and if the target person is using a network, so if you ping their IP, you won't be able to reach it because they're hidden behind the router or behind a network, then your next resort is going to be the client-side attacks. So these attacks require the user to do something. So the user is going to have to open a link, they're going to have to install an update, they're going to have to install a picture or open a picture, or they have to interact, they have to do something. And once they do it, we will be able to run code and achieve our goal. Therefore, because it requires user interaction, information gathering is very important in this case, and we don't only need to get information about the installed applications, we also need to know the person. We need to know their friends, we need to know the networks they use, the websites they use, if there's any websites that they frequently use and trust. Therefore, the information gathering section in here is going to be focused on the person rather than focused on the applications and on the operating system. So I also want to show you my lab for this. So obviously we're going to be using the Kali machine for the attacking, and the victim or the target is going to be using the Windows machine. So again, I'm just going to go over the networks just to show you that they're both on the same network. They're both using the NAT, the 10.20.14 NAT. And if we go here, we have a NAT network as well, and it should be the 10.20.14 as well. So both devices are on the same network, but it really doesn't matter. Even if they're on different networks, these attacks will work anyway. But we're going to be using reverse connections in most of them, so you don't really need, the target doesn't really need to have a separate, real IP address. In this lecture, we're going to learn how to generate an undetectable backdoor. A backdoor is just a file that, when executed on the target computer, it'll give us full access to that computer. So it'll basically allow us to hack it and do anything that we want on that computer. There's a number of ways to generate backdoors, and what we're interested in is to generate a backdoor that is not detectable by antivirus programs. Now, this is not very hard to achieve, as you'll see, and we're going to do this using a tool called Vil Framework. Now, I already have Vil's project page open in here. I'm going to include its link in the resources of this lecture on the top left. Now, if you're not familiar with Git, this is a version control system that allows programmers to host, share, and update their programs. So, to download something from GitHub, all you have to do is click on the green button in here, copy this link, and then go to Terminal, navigate to the location where you want to download this project, and in this example, I want to go to OPT. This is the directory where you should be installing optional software, and if I do ls, you will see I only have one directory in here called teeth. So, to download Vil in here, all you have to do is, first of all, write the git command, which is git. And what we want to do is we want to clone a repository. And the link for this repository is the link that we copied in here from the green button. So I'm just going to paste it here. So a very, very simple command. We're using git to download a repository from Git. We're saying that I want to clone this repository, and the link of the repository that I want to clone is this one. So if I hit enter now, you'll see it's going to download it for me. And once it's done, if we do ls, you'll see we have a new directory called Vil. And we can navigate to this directory by doing cd vil. And in here, if I list, you'll see we have a number of files, but the main file for the program is this one, vil.py. But we can't run this file right now because we still didn't install this tool. Now, Vil relies on a large number of libraries and third-party programs, so you're going to have to install all of these first before you can use it. Now, luckily, you don't have to do this manually because Vil comes with an installation script. Now, this script is placed in the config directory, so we have to navigate in this directory first. So we'll do cd config. And if we list here, you'll see we have a file called setup.sh. Now, as the name suggests, if you run this file, it will install all the needed libraries and third-party applications that Vil uses. So, to run an sh or a bash file from the terminal, all you have to do is type // followed by the file name, and in our case, it's called setup.sh. Now, you can run the setup as is like this, but I want to add two arguments to this. The first argument that I want to add is the --silent. This argument will run the installer as an unattended installer. So basically it'll install everything with its default settings and it won't ask us to configure anything. The next argument that I want to add is the --force, so that in case you're running this a second time, if you already installed Veil and something went wrong and you're installing it again, the force argument will overwrite any existing installations. Now, I didn't just figure out these arguments myself. If you actually read the description here on the project page, you'll learn exactly how to install it and what each of these arguments do. So I'm going to hit enter now. And as you can see now, it's going to automatically gather information about my current operating system. It's going to install the needed libraries and the needed applications. This might take some time because it's going to download a lot of packages. So please be patient and give it its time. Now I'm going to pause the video because this is going to take some time and I'll continue recording once it's done. So right now, as you can see, the installation is finished and it's telling me that everything is done. So I can run the tool now, but what I'm actually going to do is I'm going to first close this terminal window and open a new window just to show you how you'd start it by default. Because usually when you open terminal, you'll actually be in the root directory. So if I do pwd right now, you'll see I am in root. So in order to run Veil, we have to first navigate to the location where you downloaded it. And we downloaded it to the opt directory. So we're going to do cd opt Veil. Now if we do ls, you'll see we have the file that I told you that's the file for the program. And we have the config directory where we were and where we ran the installer. Now we've already installed everything, so we don't need to run the installer. And to run Veil, all we have to do is type // followed by the program name, which is veil.py. I'm going to hit enter. And as you can see, the program is working with no issues at all. Now, in the next lectures, I'm going to show you how to use this program to generate undetectable backdoors that can be used to hack Windows computers. Okay, now that we installed Nexpose successfully, let's see how we can run that tool and see what that tool is. I know we spoke about it a lot and we went through the installation process, but you still haven't seen what the tool does. So the first thing before we can run the tool, we need to make sure that the database that comes in with Kali Linux is turned off, because Nexpose uses its own database. So if we have both of them running on the same port, they'll conflict with each other. So the first thing we're going to do, we did that in the previous lecture as well before we installed Nexpose, but I just want to make sure that you have it in your mind that every time before you run Nexpose, you turn off your database. So you do it using the same command that we did it in the previous lecture. So at service, host, stop, and that will make sure that the service has been stopped. Now we're going to navigate to the location where we installed Nexpose. So unless you change the location during the installation process, it should be installed in, so we're using the cd command to navigate, and it should be installed in opt rapid7 Nexpose. And then the file that runs the server is stored in the directory called nsc, and the file that you want to run is called nsc.sh, this file. So we run it just the same way we ran the installer before. As I said, to run an executable, you always use the // and then you write the name of the executable. So it's nsc.sh. Now, running this for the first time might take some time, so just let it do its thing until it runs. And once it finishes loading the framework, we'll see how we can access it and use it. Okay, so the tool has loaded successfully, and as you can see that it's telling us that we can browse it using the following URL. So what we're going to do now is launch our browser and just paste the URL that it just gave us. Now, it's asking us to log in, so log in using the username and password that you created when you installed the tool. So my username was Zaid, and I'll put my password. Okay, and we logged in successfully, and you can see that the first thing it asks us to do is to enter the product key. Now, as I said, this is a free version, and when you downloaded the tool, you had to fill out a form. So in that form, you put your email address, and then they send the product key to your email. So I'm just going to go to my email and get the product key and paste it here. Okay, so I'm going to paste it, and click on activate the key. Now, as you can see, the activation is successful. It's going to refresh now. Now, I actually paused and resumed the video because the activation takes some time as well. I just don't want to make the video boring. Now, as you can see, this is just showing us information about the license. So everything is activated and we're good to go. So I'm going to go to the home from here, from the left menu. So this is the home page of the tool. And as you can see now, everything is empty. So before I start talking about what everything means, let's go ahead and add a target, and then we'll do a test and we'll see, because this stuff will be filled after we do a test. So the first thing I'm going to do is go on create and go on a site to add a target. And I'm going to call this target Metasploitable. And I'm going to go to the assets, and we're going to add the target. So the target can be arranged the same way we added it when we were doing the network penetration things with ZenMap. So you can add a range, or you can add a specific IP. So in this, we're actually targeting the Metasploitable machine. So we're going to add our target, which is 10.20.14.204. Confirm this here. This is our Metasploitable machine, 10.20.14.204. And we're going to add this to a group, and we call that Metasploitable as well. Or we'll call this test. So this is our group name. Now, in here in the authentication part, if the target uses some sort of authentication, so nobody can access the target unless they need to authenticate with some sort of a service. For example, if it's an FTP service or a web HTTP authentication, a telnet, or an SQL server. So you can pick it from here, put the domain, username, password, confirm your password, and that way the framework will be able to authenticate with that service and test the security of your server. Now, our server doesn't use any type of authentication, so we don't need this. Also, if you're targeting a web application and the web application has a login page, for example, for users, for example, Facebook, let's say you're targeting Facebook, then you won't have access to most of Facebook's features unless you log in with using a certain username and a password. So again, using this feature here, you can log in and then test the security of your target. And the templates is where you select the scan type. So it's very similar to the scan type with ZenMap. We've seen in ZenMap we had a quick scan plus, and intense scan. This is the same. So each one of these profiles is different. It scans different things. For example, we have the full audit here, which takes a lot of time, but pretty much checks for everything. Then you have a full audit, enhanced logging without WebSpider. So a WebSpider is a tool or a script that finds all the files and directories in your target. And the default one is a full audit without WebSpider, so that's the one we're going to be doing. And you also have network specific profiles, you have web audits as well. So I really encourage you to try all of them or most of them and get yourself familiar with them. Now we're only going to try this one because using them is the same, which will be scanning for ICMP, TCP, and UDP ports. So I'm leaving that the same. I'm going to leave the engine the same as well, which means it's going to use our local engine, which we installed, instead of using the one that is provided by Rapid7. In the alerts, you can set up custom alerts so that when a vulnerability is found, you get a notification. And the schedule is a really, really cool feature. Now, say you're working for a company or for an enterprise that keeps pushing new code every day. Or, for example, maybe your code, you do a test today and everything you're working on is good. Your web servers, your programs, your applications, everything is up to date and there's no vulnerabilities in them. Let's say tomorrow you pushed a new vulnerable code, or maybe tomorrow someone discovers a new vulnerability with a program that you're using on your web server. So you're not secure anymore. So this feature allows you to schedule this test so that it runs every week or every hour or every month, depending on how critical it is. So all you have to do is just go in to create a schedule and create the schedule. So you can put a start date and an end date, and you set up the frequency from here for every day, every Thursday, every 26th, or depending on what you want really. You create that schedule, and then every interval that you specify, the scan will run, and even you can get it to produce a report for you, so you can go over the report and see what's changed or what has been discovered. So everything's good now. The most important part today, or what we did here, is you put your target here, and the next thing is you select the template. So we have both of them selected, and we're going to do save and scan, which will save this configuration and start a scan for us. Now, as you can see, our asset discovery is in progress. I'm going to pause the video, and after that, we will talk about the results that we got. Okay, so my scan is over, and I'm here now at the assets page. And as you can see that we have one asset has been scanned. We can see that the asset is running Ubuntu, and the skills that you need to hack into this asset is Novice. Now already from this you can see that Nexpose show us much more information than Metasploit Community, and it's a much more advanced vulnerability management framework. We can see that we scanned one target. It's Metasploitable, and the site is global. Let me zoom in. It's running on Ubuntu Linux 8.08.04. We discovered no malware and 177 exploits, 308 vulnerabilities. Remember, with Metasploit Community, I think we only discovered 8. Only one exploitable vulnerability and 8 modules that can be used. Here we discovered 308 vulnerabilities, so we discovered so many more vulnerabilities and exploits. You can see that there is a risk factor assessed to this, and the last time that the scan was done. Now, if we go down, we can see that the operating system that we discovered, again, it's Metasploit. We can see the software that is installed on the target computer. So not only the services that's running on ports, we can see actual software installed on the target computer. This can be very useful after we hack the computer. So after we manage to hack into it, it's very useful to find local exploits that can be used to increase our privileges. For example, if you got a normal user and you want it to become a root, then you can use a local buffer overflow to increase your privileges or to do other kind of stuff. So these are very useful in terms of post-exploitation. If we go down, we'll see the services that's installed on the target computer, just like Nmap gave it to us. We can see that HTTP is running, DNS, and so on. If you click on any of these services, you'll see that it'll give you more information about it. For example, it's a HTTP service, a description about it, and the ports that it's running on. So we can see that HTTP is running on port 80 and on port 8180. Now let's go up, and if we wanted to have a closer look on the vulnerabilities, we can go to the vulnerabilities page here, and you can see we have a graph here about the vulnerabilities categorized based on their risk factor. And here they're categorized based on the skill level needed in order to exploit these vulnerabilities. And in here, you can see a list of all of them, and we can switch between them using this right here. Again, this, if there's any malware, you'll see it in here. And if there is an exploitation, you'll see it in here. Now, all of the top vulnerabilities here don't have an exploitation using a tool, but they are ordered based on their risk. So these are very risky vulnerabilities. And then as we proceed through them, the risk will be a bit less. So you can see here, it discovered that VNC password is password. So we can go in and try to connect using VNC. Now, VNC is a service very similar to remote desktop. Basically, it will show you the desktop, and it will allow you to gain full access to the target computer, just like remote desktop. I'm not going to show you how to do that. Very simple. But it's telling you here the password is password. Now, it's also telling you that there is a backdoor running, and we use that already. It's telling us that it's running an old version of PHP that can be exploitable. Just an old version, actually. Now let's look at something that can be exploitable. So I'm gonna click on this to order them by the exploit, and you can see that all of these have an M logo, which means that they can be exploited using Metasploit. You can see here we have the remote shell service that we use, and there is the rlogin service here that can be used as well that we already had a look on. So let's click on something that we haven't seen before. And here you can see a description of this vulnerability. Again, you can see the port that it's running on, and you can see why it thinks that this particular target is vulnerable to this exploit. If you go down, it will show you how you can exploit it. So there's 3 different modules that can be used to exploit it. It doesn't really have to exploit it. Sometimes you just see modules that can be used to verify the existence of this exploit. But basically, these are modules associated with it. And if we click on this, it'll take us to the Rapid7 page that we always used to see when we Google stuff. And we see the module name where we can just copy and paste it in Metasploit and show the options and then use this exploit the same way that we've seen it in previous videos. Again, when you go down, you'll see references to this particular exploit. And at the bottom, it will show you the solution on how you can fix this exploit. So for this one, all you need to do is just change the administrator password and not use the default configuration. Another useful thing is the reports. So this framework allows you to generate reports for each scan that you do. And there is different types of templates for the report. So if you go on create report, you can see that there is an audit report that contains a lot of information, detailed information for the programmers or for the technical people. Or you can use an executive report, which has less information, and it's made for the managers or for the top level people that don't have much experience with technical stuff. You can select any template you want, call it anything. So I'm going to call this Metasploitable or Metasploit. And you select the format that you want. So it's set to PDF here. Then I'm going to select the target scan that I want to generate a report for. And I selected my Metasploitable. And then you save and run the report to generate the report. You can also get this to generate reports automatically every time, because as I showed you, you can schedule reports, you can schedule scans, and you can also schedule an automatic report after each time a scan is done. So for example, if you're scanning every week, you can also generate a report every week, every time that scan's done. Now let me just download the report and show you what it looks like. As you can see, it has the date, it has the title, it has all the exploits that have been found, but this is the executive report, so it has small details about the exploits and more graphical stuff to show the executives the risks that has been found and how critical they are. So as you can see, Nexpose shows you much more detail and it's much more advanced. It's directed towards bigger companies, bigger infrastructures, where you need to always make sure everything is up to date and everything is installed and does not have any exploits. In this lecture, I'd like to talk about a tool called Nexpose. Nexpose is made by Rapid7, so it's made by the same people that made Metasploit and Metasploit Community. And it's similar to Metasploit Community in a sense that it has a web GUI and it allows us to discover, assess, and act on discovered vulnerabilities. It also maps these vulnerabilities to existing exploits, but the difference is Metasploit Community only showed us exploits that can be used within Metasploit. Whereas with Nexpose, it actually shows us exploits that have been published somewhere else other than Rapid7 and Metasploit. So it works on a larger scale, it shows us more vulnerabilities, and it also helps us to create a report at the end of the scan so that we can share it with the technical people, and a small report which is of a high level that can be shared with the managers. It also helps us create scheduled scans so that, for example, if you have a company or if you're working on a big infrastructure and you want to do regular scans every week or every month, then you can do that using this tool. Let me show you how to install it and run it, and the differences will become more clear. So Nexpose doesn't come installed in Kali Linux. We have to install it manually. To download it, you need to download it from the following link. It'll ask you to fill up your name and address and all that, fill it up and download. I downloaded the community version, which is free. So I have it right here. Now what I'm going to do before we can install it, the first thing we're going to do is stop the PostgreSQL service that comes installed with, or that is running in Kali Linux. So I'm going to do service, post, stop. That will stop the service, the SQL service. Now, I'm actually already at the downloads folder. So usually when you run your Terminator, you will be here. So you'll be, if you do an ls, you'll see all the directories, and you'll need to change your directory to the downloads directory by using the cd command. So cd and type in downloads. Now, once we're in the downloads, we can list all the available files, and we can see that we have Nexpose right here. Now, usually you'll have this, you'll need to change the permissions of this to an executable. Now, I've already changed it, that's why it's in green. So for you, for the first time, you need to run a command, the chmod command, to change the permissions so that we can execute that file. So the command will be chmod +x, and you type in the file name that you want to change the permission, and for us it's Nexpose. And that's it, the permissions are changed. Now, to run this installer, to run any executable in Linux systems, all you have to do is dot and /, then type the file that you want to run. So for us, it's Nexpose. Now, as you can see, you get a nice installer for it. So I'm going to click next. Now it's asking me to accept the agreement. And I'm going to install the console with the scan engine. Now, as you can see, one of the problems that I have here is that it's not supported with the Kali Linux version that I have. I have the latest rolling version of Kali Linux, and Nexpose is not compatible with it, so it's not going to let me install it. Now, it's only compatible with Kali 2, so if we want to proceed and go ahead with this, we're going to modify 2 files on our local system to make our system look like Kali 2, so that the installer will let us install it on our system. Now, hopefully, in your case, by the time you watch this video, there will be a supported version, so you can just click next in this step. But for me, I'm going to have to go in and modify 2 files to make my system look like Kali 2. So follow the steps that I'm going to do now only if you get this error. So I clicked on finish, and I'm going to go here. I'm going to attach a file that contains the instructions that you need to do to fool or to change the version of your system to Kali 2. So I have it here in the documents. The two files that need to be changed are the LSB release and the OS release. So I'm going to open two tabs in here, one for each file. And the first one is in etc. And it's called LSB release. And we can see that the file here. Now, before I modify this file, I'm actually going to copy it and store a backup of it, because after we finish this step, I'm going to restore it to the way it was. So I'm going to create a new folder and I'm going to call it backup. And I'll paste this file here. And after I do that, I'm going to modify the file according to the instructions. So I'm going to open it with LeafPad. And I'm going to copy all of this. I'm going to save it and quit it. Now I'm going to do the same with the next file, which is the OS releases, which is stored in user lib OS releases. So I'm going to copy this and put it in my backup. Then I'm going to modify it according to the instructions. Okay, now everything is done. I'm going to go back and run the installer again. And it should think that I have Kali 2 installed and let me proceed through the installation. So again, scroll down, accept, next. And as you can see that it thinks I have Kali 2, so it's letting me proceed through the installation. Now I'm going to put my name, my last name, and the company. And now it's asking me to put the port for the database that's going to be used with Nexpose. Now that port is already been used with an already installed database, so I'm going to make the port 5435. And as you can see, it's telling me that the port is valid and can be used. So I'm going to go next. Now it's asking me to make a username and a password for login. So I'm going to make a username and I'm call it Zaid. And then I'm going to select my password. And make sure you don't check this box. Now I had a lot of issues when I was checking this box while installation, which basically should start Nexpose once the installation is over. But I'm not gonna check it. I'm just gonna install it and then start it later when we want to use it. So I'm not gonna check this box. Make sure it's unchecked. And that's it. Now it's going to install it for me. I'm gonna pause it and resume once the installation is complete. Okay, so the installation is successful and we didn't start Nexpose yet. So if you go on this link, nothing's gonna work. You need to run this command first, and then you can access it. So we're going to talk about that in the next lecture. For now, that's it. I'm going to click on finish and we're done. Now we're going to go back and make sure we set our files back to the way they were. Now, if you didn't need to modify them, then again, skip this step. If you did modify them like myself, then make sure you go back and you set them back to the way they were. So I'm going to go on my backup and I'm going to open these files. So we're going to do the OS release first. I'm going to copy it. And modify the existing one and make sure it's the same as it used to be, the rolling one. As you can see, it says Kali 2 here. I'm going to set it back to 2016. And then I'll do the same for the next file.